Question 12, Part E. The diagram shows the parabola y equals x squared over 2 with focus S 0, 1 over 2. A tangent to the parabola is drawn at P 1, 1 over 2. Part 1. Find the equation of the tangent at the point P. To find the equation of a tangent to a point on a curve, we need the gradient of the tangent at its point of contact as well as the coordinates of its point of contact. Now the coordinates of its point of contact is 1, 1 over 2. To find the gradient of the tangent at its point of contact, we need the gradient function y dash. Now the curve is y equals x squared over 2, which represents a parabola. So differentiating y with respect to x, we get y dash is equal to 2x over 2, which simplifies to x. So the gradient function is y dash equals x. So the gradient of the tangent at its point of contact is equal to its x coordinate, since y dash equals x. And the gradient of the tangent at the point P, 1, 1 over 2, is 1. We have the gradient, we have the point of contact. We can now use the point gradient formula to find the equation of the tangent at point P. So y minus y1 is equal to m, or y dash, times x minus x1 in brackets. We get y minus 1 over 2 is equal to 1 times x minus 1 in brackets. And that simplifies to y minus 1 over 2 is equal to x minus 1. And adding half to both sides of the equation, we get y equals x minus 1 over 2. Part 2. What is the equation of the directrix of the parabola? The focus S has coordinates 0, 1 over 2. So A is equal to 1 over 2. So the equation of the directrix is given by y equals negative A, which in this case will be y equals negative 1 over 2. Part 3. The tangent and the directrix intersect at Q. Show that Q lies on the y-axis. To find the x-coordinate of the point of intersection, we solve simultaneously the equations y equals x minus 1 over 2 and y equals negative 1 over 2. So using the substitution method, we get x minus 1 over 2 is equal to negative 1 over 2. Moving the negative 1 over 2 from the left-hand side over to the right-hand side, we get x is equal to negative 1 over 2 plus 1 over 2, which equals 0. So the x-coordinate of the intersection point is 0. Therefore, the tangent and the directrix intersect at point Q, which lies on the y-axis. Part 4. Show that triangle PQS is isosceles. Point Q lies on the directrix and the y-axis, hence the coordinates of Q are 0, negative 1 over 2. Now I've shown the point Q on the sketch here for visual reference. We can see the point S, which is the focus of the parabola, with coordinates 0, 1 over 2. So point S is directly above point Q, or we can say that Q is directly below point S. Now point P is directly to the right of point S, and it's directly to the right because the y-coordinates of point S and point P are identical. So the vertical distance of points S and P above the x-axis is the same. So SP is a horizontal line, and the distance or length SP is the difference between their x-coordinates. So SP is equal to 1 minus 0, which equals 1 unit. Now point Q lies directly beneath S, hence SQ is equal to half minus negative half, so it's the difference between their y-coordinates, and that also equals 1 unit. So because we have SP equaling 1 unit and SQ equaling 1 unit, we have an isosceles triangle because we have two equal sides. So SP equals SQ, therefore triangle PQS is isosceles because there are two equal sides.